So I would like to welcome our National President, Mr. Chandrasekhar, Mr. President-elect, Mr. Yogesh Thakkar, Mr. Srinivas, National uh, Chair, Youth at ISHRAE, and all the members, zonal chairs, youth, and all the ISHRAE members, youth members, and the student members who are available today to live this show, which is ISHRAE Prime Time. So I would like to welcome all of you in this show. This is first such unique initiative for this society here. This is being organized by Youth at ISHRAE. And for this, we have the panelist with us, Mr. Sagar Munishwar from West, Mr. Yash Sen from North, Mr. Prakash from South, and Mr. Anand Babu Rao, who is the panelist for this show today with us. And we are going to discuss high-rise, importance of HVAC in high-rise buildings. So this is, I'm sure, very good. Looking forward to have a great discussion during this panel discussion. So over to you, Mr. Imran, please.
Thank you, sir. We are fortunate enough to have our National President, Chandrasekhar sir, with us. So I request Chandrasekhar sir to please address the gathering.
Thank you, Imran, and good evening. Youth team in ISHRAE is always a vibrant team. In fact, sometimes I feel why we are having this, that less than 40 years is youth. I think we should have less than 65 years is youth, because then I can consider myself as also part of the youth, and all of ISHRAE will become youth. I think it is high time I change this. No, I do not know. I will seek the help of our committee to work on this, but I can tell you the amount of dynamism which the youth team brings to us is something which is which is I would say is contagious. You know, it spreads amongst us, and even people like me so start feeling like youth. So it is only because of them. And today's topic is a wonderful topic which you people have taken. We have this year's society team, the theme which was played out just a few minutes back, Prithvi, Paryavaran and Parivartan. And when we want to save the Prithvi, when we want to take care of the Paryavaran, and when we want to have Parivartan on that, there cannot be a better topic than high-rise buildings. And what ISHRAE, being a technical society, the heating, ventilation, air conditioning and refrigeration can contribute towards that. You all know that our Prime Minister, Honorable Prime Minister, has got a vision where he has declared that India will be net zero in emissions by 2070. There are various steps to that is also been announced, and how, as a HVAC fraternity we can contribute towards that. And in line with all those things is what our theme of Prithvi, Paryavaran and Parivartan is there. And there is no great thing which we can talk today and enlighten the audience who are present here. And I am sure even if somebody is not able to join today, you please put this recording on our YouTube channel. People will watch this for many times, because the amount of information that can be taken from here, because today the landscape of India is changing a lot. The landscape of India is moving over from a horizontal integration to a vertical integration. When we are moving towards a vertical integration, we are not only saving in terms of many things, we can conserve many things. So that is what can come into the fore. I would not like to take more time and giving anything talking about this, because I know esteemed panelists are there. You all have a great vision in this. I am willing to listen to you people. I want to be here. And this is the one place where anything would have not stopped me from missing it. So I am here today with you all. Thank you for this opportunity, and have a great panel discussion today. Thank you.
Thank you, Chandra sir. You are an inspiration to us, and the theme has inspired us to come up with this particular topic. Thank you very much, sir. And we have Yogesh Thakkar sir, the National President-elect, with us. So I request you, sir, to please address the gathering.
Good evening, everyone. It's a honor for me to be with the youth. As Chandra sir rightly told, we at ISHRAE really consider the youth. We give importance to our youth, and this is a real great program, innovative program, which the team, Srinivas, Moni, Imran, you have come out with prime time, and I'm really looking forward to this. And there are going to be many more such panel discussions and seminars under the prime time label. And I am looking forward to hearing to all the four esteemed panelists, Yash, Sagar, Prakash, and Anand, all diversity from Northeast, West, South. The topic is also a good topic. And my best wishes to the youth team. Let the prime time continue and more useful, constructive, interactive seminars and group discussions and panel discussion happen under the leadership of Chandra's tenure. And of course, I am also looking forward. I see a good participation of 59 people, and more people will be joining. So after the COVID period opening up, people are more interested in things. So I am looking forward to a great participation in this virtual event also. All my best wishes. Thank you.
Thank you, Yogesh sir. And I would like to welcome everybody on board today. And I'll just like to give a small brief about our speakers. So I request Minu to please share the screen and presentation. And there is a small input that we are live on Facebook. So I request all the ISHRAE members to please share these details among your circle. So we have today's panelist from South India, Dr. Anand Babu. So I'll be introducing Dr. Anand Babu. Welcome, Dr. Anand Babu.
Thanks, Imran. It's a pleasure being part of this. Looking forward for the wonderful discussion. Thank you.
Thank you. Dr. Anand is working as an associate consultant in Genex Consultant for last 11 years. Prior to that, he had worked 8 years in various countries in Middle East as a project manager. He has involved in many projects such as hospitals, high-rise buildings, hotels, malls, etc. And he has an overall experience of more than 19 years in the field of HVAC. Dr. Anand was part of design for many prestigious projects such as Sharat City Capital Mall, which is one of the biggest mall in India, various strategic projects for Ministry of Defense. He has involved in design of over 100 operation theaters, PMT rooms, cancer blocks, negative positive rooms, COVID wards, and designed many prestigious hospitals in India as well as abroad. He has designed projects which has received awards in India as well as abroad for efficient design and energy conservation methods. He is ECBC expert and ECBC TPA in AP. President of ISHRAE Deccan chapter for the year 2020 and 21, and one of the hybrid. He was one of the first hybrid president or online president, we can say, for ISHRAE Deccan chapter, and also held various posts in the chapter. He was chair for Innovation Hub in Refcold, Hyderabad, member Healthcare TG Group, National Conveyor ACRESERV, vice chair ICP, mentor for ISHRAE Vijayawada chapter. He is also member of ISHRAE and part of various technical groups. So I take this opportunity to welcome Dr. Anand Babu on board for this panel discussion. Welcome.
Thanks, Imran. I can put it as I was the president of COVID batch, so you can put me in that way.
Yes, that's certainly. Next slide, please. We have our second panelist who is representing West region. Sagar Munishwar sir, welcome to this panel discussion. In 2004, he has completed his mechanical engineering from Mumbai University, postgraduate diploma in piping from VIT Pune, EXIN USA accredited certified data center professional CDCP, and diploma in yoga 2005. He has more than 17 years of experience as specialist consultant in MEP services, currently working with SCAM Consultant Private Limited as Director Projects. In the journey of 17 years, involved in designing of multiple hotels, hospitals, IT parks, townships, etc., including high-rise projects all over India. Involved in few international projects like Sheraton Hotel in West Africa and International Airport in Philippines. Member of ISHRAE, ASHRAE, and member of Fire and Security Association of India. Major position held in ISHRAE as follows: Secretary of ISHRAE Thane Chapter, Treasurer of ISHRAE Thane Chapter, CWC Conveyor Urjavaran ISHRAE Thane Chapter, CWC Training Chair of ISHRAE Thane Chapter, and founder member of ISHRAE Thane Chapter. Welcome, Mr. Sagar Munishwar.
Thank you, Imran. Good evening, everyone. It's a pleasure to be on the prime time. Thank you so much.
Thank you and welcome, sir. Next slide. We are fortunate enough to have our panelist from East Zone, Mr. Prakash Kumar. Mr. Prakash Kumar, BTech in Mechanical Engineering from NIT Nagpur, having 11 years of experience of working in ACVS and mechanical design. Currently working as manager in mechanical design, Mecon Limited as a PSU under Ministry of Steel. Welcome, Mr. Prakash Kumar.
Thank you.
Let me take this opportunity to welcome our another panelist, Mr. Yash Sain from North Region. Yash Sain is a mechanical engineer, have 8 years of experience and extensive exposure in HVAC design, project execution, project management, cost analysis, and quality check. Have international project experience with geothermal heating and cooling, radiant heating, mechanical heat recovery ventilation, aerothermal system, solar PV, chillers, and VRF systems. Done projects requiring energy conservation measures, incorporated building, physics, and renewable hybridization. Welcome, Mr. Yash Sain.
Thank you so much, sir. Very good evening to all. And it's always, I'm always curious to exchange the knowledge because climate change is, we have some policies, so we have to work together for it. So thank you so much for the opportunity.
Thank you and welcome, Mr. Yash. Next slide, please. So welcome everybody to ISHRAE Prime Time, which is being organized by Youth at ISHRAE, HVACR Industry Wants to Know. And we have our Prime Time, Mr. Srinivas K. Welcome, Mr. Srinivas, who is National Chair for Youth at ISHRAE.
Thank you, Imran. A very good evening to everyone. A warm welcome to a most awaited program, ISHRAE Prime Time. HVAC Industry Wants to Know. Actually crossed my fingers the start of the program that this is the first event that after post-pandemic we are doing, and I was more awaited that how many participants will be there. And thank you everyone for joining this prime time in the evening. Today's topic is on the decentralized air conditioning system for a high-rise buildings. What is the Indian real estate plan of action to spread infrastructure vertically or horizontal? What are the pluses and minuses, the pros and cons of adding skyscrapers? How the building are sustainable and energy efficient when it grows vertically? What are the key considerations in the designing the high-rise buildings? Are we ready with the technical infrastructure for the skyscrapers? How digital building technology will support the high-rise buildings. So we would like to know from our expert panelists today that what is their opinion and what we can conclude at the end of this discussion. Thank you very much for joining, and let us wait and see this, hear from our experts, and over to Mani and Imran. Thank you.
Thank you, Srinivas sir. Also, I take this opportunity to welcome my partner, Mr. Manikana, who is the National Vice Chair, Youth at ISHRAE. So we both will be moderating this panel discussion. So next slide, please. Welcome, Mani sir.
Thank you.
So before we get into this panel discussion, I just quickly take you through a quick ride that what is a quick overview of design of high-rise building, past, present, and future. Next. So when we talk about past, how the high-rise building used to be, we have a historical evidence that high-rise building used to exist. So while cities like New York, Chicago can be considered as a birthplace of modern high-rise buildings, the history of multi-story construction is much older. The tower houses of Shiban in Yemen, you can see the picture. It dates back to 1600 AD, representing one of the earliest examples of human habitation in multi-story construction. So these sun-dried mud brick tower houses have constructed up to 7 stories tall, providing security as well as prestige for their inhabitants. In a dense cluster of 500 or so, these tower houses have earned a World Heritage listing in UNESCO in 1982, and the nickname is Chicago or Manhattan of the Desert for the old city of Shiban. Next. So when we talk about past, what were the driving forces like social and economic and technical developments in the later parts of 19th century created the environment for modern high-rise buildings to emerge in northern American cities of New York and Chicago. Perhaps the two most important technological factors contributing to emergence of modern tall buildings were advancement in steel structures and vertical transportation, that is lift. Gustav Eiffel used pre-assembled iron components to design and construct his 300-meter plus tall tower in Paris, which is known as Eiffel Tower now. And in 1952, Elisa Graves Otis built the first fall-safe hosting system, which we call as elevator now. Next. And then when we talk about today, the increasing rate of urbanization in recent decades has seen an accelerated trend in construction of high-rise and tall buildings worldwide, particularly in the emerging economies of the world. A fundamental economic driver for the growth of tall, particularly residential buildings, is scarcity of land in the dense urbanized parts of the world. The competition for constructing the tallest building in a city, country, region, or world has acted as another driver for the growth of tall buildings worldwide. Next. These are some examples of skyscrapers. So in the past decade or so, the race for constructing the tallest has been extended to include the contest for constructing the most iconic and spectacular high-rise building, often categorized by complex geometries and leaning or twisting forms, like you can see as an example here. Next. So what will be the high-rise building for tomorrow? Although the drive to deliver good functional and economical design for high-rise buildings is unlikely to change fundamentally, the focus on producing energy efficient and sustainable design is expected to increase at an accelerating pace. This is a response to the fact that buildings consumes 40% of the energy use, 40% of material use, 30% of waste generation, and 15% of water used globally, and that tall buildings are proportionally more material and energy hungry than lower rise buildings. In high-rise buildings, the structure is a large portion of the overall cost and embodied energy, and hence the structural engineer can significantly influence the overall sustainable design outcome. Next. So when we talk about tomorrow's scenario, the sustainable structure design goal can be achieved by addressing the three objectives: reduce, reuse, and recycle. Advanced analysis and design methodologies are allowing us to design increasingly more efficient structures with just the required amount of material and no more. Also, new material technology is opening the way for reduction of embodied energy per unit of material in terms of transport energy, sustainable supplies, and the like. The use of industrial byproducts such as fly ash, slag, and all these substances can drastically reduce the embodied energy of the concrete. So with this, I believe that the audience got a sound idea that what we are going to discuss in this panel discussion. Next slide, please. So let us begin with today's ISHRAE Primetime HVAC industry eagerly wants to know. So let's go ahead with the first question to our first panelist, Dr. Anand Babu. Next slide, please. So we need an expert opinion on this, that as per the theme of society here, Prithvi, Paryavaran and Parivartan, how do you relate the high-rise buildings design like Prithvi, geological location, Paryavaran, sustainability, Parivartan, energy saving features? Dr. Anand Babu, we want your expert opinion on this.
Thanks, Imran. I think this is a wonderful question. I never expected that, our national theme to come up with the high-rise building kind of a concept. So I need to actually think about what kind of answer suits to our national theme. Basically, whatever we day to day activity we see, or the design, whatever we design in our HVAC field or the architects. I think this all revolves around Prithvi, Paryavaran, and Parivartan. That's what if I can put it. Now, I was, the other day I was going with some document. It was an interesting fact. What I got was like the total land area in square meters per capita per 1,000 persons. Greenland is very high, like, for around, they have around 38,000 square kilometers for 1,000 people. When you talk about USA, which is a developed country, they say around 30.16 square kilometers is for, like, for 1,000 people. But when you talk about India, it is 2.59 square kilometers per 1,000 people. So you can see how much ratio we have, compared to the land and to the people available. So we need to think how we can grow. I mean, all the cities now, we have a lot of smart cities coming up in India. We have all the mega cities going much more mega, and they are developing much wider. So as it is, we are putting a lot of I can say stress on our Prithvi as such, because we are creating a lot of we need to create a lot of facilities for our human being. So of course our Paryavaran is also getting affected by that. So we need some kind of Parivartan for this. So when we talk about high rise, I just want to mention a few things. Like high rise is only, it is up to 15 meters height. That is above 15 meters height is called high rise building. But later on, there are buildings which are called tall buildings. Then it is super tall buildings, and then mega tall buildings, which are like 100 meters, 200 meters, or 300 meters height. So we are only talking about the basic, which is above 15 meters to 30 meters height buildings. Now, if we talk about a building like Burj Khalifa, which is almost around 830 meters height, which is the tallest building as of now what we have. Coming to your question of how this high-rise building to our our theme of our society here. As you know, as I was mentioning, 2.59 square kilometers per 1,000 people. That means we can't laterally develop. I mean, we don't have land to develop laterally. Only thing we can develop is vertically. Like even Chandra was mentioning, so we have to develop only vertically. So how can we develop vertically is through the high-rise building. So by that, what you're doing is we are minimizing the land area which is used for construction of the buildings. So in a very small area, you can actually go with a high-rise building. If you talk about a small apartment, which can accommodate around 6 flats to 8 flats. But if you go with the individual villa, the area required is much more. So the actual area, like if you go with the 10 houses than an apartment, the facilities required, like in your roads or your electricity or all the other feature requirements, the basic requirements, the water, the drainage, is much more compared to your high-rise buildings. I mean, I'm talking about laterally. Coming to the Paryavaran thing, yes, of course, when you have so many people involved into this in one place, one building, so you can actually think about better which are available in the market for the design and all things. So all whatever you can provide or you can have as a design, so you can put it in a high-rise building rather than going in an individual building in a villa. Of course, this when you talk about having good, it's not only about HVAC system, but also about the plumbing or the firefighting system or your electricity, the lights and all the things. So you are going to save a lot in that. So that all will actually have a better energy savings in our buildings when you talk about a high-rise building, because you have a control on that. When you talk about a high-rise building, we have a control. There is some kind of a system which we can do it. When you talk about individual villas and individual houses which are laterally there, the control is not there because it depends upon the individualities. So this actually suits our team as a national team towards a high-rise building. So it actually reduces your land area. It takes care of our Paryavaran. Of course, the Parivartan which is required for us, it also takes care of that. So this is, I think I've given a small gist of what exactly it is. Of course, this is a very big subject where we can discuss, but I think we have a lot of panelists where they have their opinion to say. Back to you, Imran.
Thank you, sir. Over to Manikanna.
Yeah, thank you very much. And can you please go to next slide? So I have one question for the other panelist, Mr. Prakash Kumar. And the question is, it is important that high-rise buildings shall maintain and ensure the ventilation and thermal comfort. On this note, how to deal with the challenges of ensuring HVAC systems, plumbing requirements, and how one can meet these challenges. So, Mr. Prakash Kumarji.
Hi, everyone. I think this is a wonderful question because piping and ducting are normally one of the most crucial part of any air conditioning system. And when it comes to high-rise building, it becomes of paramount importance because generally high-rise buildings are glass covered. So there is nothing which we can do outside the glass cover because it will damage the elevation. So now starting with chilled water piping, we generally provide a dedicated shaft from the chilled water plant, which is located at the ground floor or basement to each HU room at each floor. The chilled water chilled water shaft should be adjacent to HU room, but after erection of pipe, the common wall between HU and shaft, we ensure that it should be completely sealed. Now, moving ahead, all supply chilled water pipes should have at least provision of motorized valve along with orifice plate to ensure that pressure loss is uniform across all HUs. It may so happen that in one HU pressure loss is more and another HU pressure loss is less. So in that case, water will take the less resistant part. To avoid that, we do this. And then in chilled water piping network, we have to ensure the provision of expansion tank. It can be pressurized or it can be normal, which should be connected, at the top point of your circuit and should be placed at the roof. But I personally prefer pressurized expansion tank because that is foolproof. Now moving to the ducting part. Normally in a high-rise building, there is not only air conditioning duct involved. There are different types of ducting which do. First is supply air duct from air handling unit. We design it in a way that all corners, in fact, even the farthest corner from the HU room should be adequately cooled. And another consideration while designing is that we have to keep our depth and width of duct as minimum as possible because space is always limited in a high-rise building. Then for a smaller area, we can, in place of HU, we can use FCUs also. And now a recent development which we are doing is, actually, I would not say it recent, but for last 10 years, what we are doing is, we are using the supply air duct as, in case of emergency, as fume suction duct as well. So what we do is, we provide a motorized damper just after HU, and from there a duct is being laid to the roof, and there is a fan installed which sucks the air in case of fire. And then second type of duct is return air duct to HU unit. Normally, we can avoid this also by using the space above false ceiling. But we have to ensure that HU room should have an opening from where return air should reach the HU to get itself cooled. Now, these are the two ducts which supply and return. Now, moving to the third part, that is supply fresh air duct. What happens that once one air is circulated once again, people start getting some discomfort in the room because they're saying that lack of fresh air and everything. And in a glass covered building, we have to ensure that fresh air reaches to each HU. So what we do is we provide supplier fan on the roof, and from there fresh air duct is connected to each HU unit or HU room, just to ensure that all the occupants of a high-rise building should never feel discomfort. And second, another different type of ducting is toilet exhaust and return fresh air duct, because if smell stink from the toilet is not taken out, then again people will start feeling uncomfortable over there. So what we do is here also a fan is installed on the roof, and the suction of the fan is connected to each toilet block. Normally on each floor we provide a dedicated toilet. So from there air is sucked from each toilet, and that fan is again installed at the roof. And additionally, what we do is the same duct has a provision of sucking air from the stairwell as well, so that staircase and all areas which are normally not that much occupied but should remain ventilated. People should not feel any kind of suffocation and all. So, and the last part is kitchen exhaust duct. Normally in a high-rise building, they are basically commercial building where different offices are there. So we provide mess, or we have a kitchen normally in the lower floors. So again, kitchen exhaust or kitchen smell, it should not reach to other floors, because again people will start feeling not comfortable with all kind of smell. So here also we do the same. We install a fan again at the roof, and that fan sucks the air from the kitchen. It may so happen that your kitchen might be in second floor and your top floor is like 25th floor, but you have to provide this ducting because there is no other alternative to this. And yeah, meanwhile, I missed one point is the toilet exhaust which we are taking out. We have to ensure that toilet exhaust or fresh supplier fan or this kitchen exhaust should never ever malfunction. So we have to provide 100% standby. I would just like to share one incident with you. I would not mention the place or project. What happened is that our return toilet exhaust fan stopped working, and then fresh air fan was continued working. 3 of the floors complained that their glass panel have broken, because you are supplying air and you are not sucking it out. So what is happening is you are creating a pressurized system in different floors. So 2 or 3 floors, I remember, they complained that their glass have broken all of a sudden. Normally what happens, 3 to 4 mm of pressure rise in the air. People, normally human beings don't feel it, but glass or other things which are not designed for that pressure, they break. And there are other things also which is coming now, like heat recovery wheel concept, then radiant cooling and district cooling concept, geothermal energy. Now with corona and all, nanofiltration and all these things. But I think given the time constraint, I would like to limit myself to this only.
Thank you, Prakash sir. Can we go to next question? I hope the audience got a well-versed expert opinion about the first question on Prithvi Paryavaran and the second question to Prakash sir. So next question is India ready with technical skilled infrastructure for high-rise or tall structure? How the critical room air conditioning is addressed in such mega structures? And this question is to Mr. Sagar Munishwar. So can you, sir, please give a brief about this question?
Yes. So thank you, everyone, and welcome everyone, including National President-elect. So first of all, when you ask this question, I would say that I feel proud to be an Indian first, and of course, proud to be a part of ISHRAE. I'll explain why. Because when you ask, is India ready with the technical skill infrastructure for high-rise and tall structure? I'm going to say, if you go back ages, tall structures in India is not new. You know, even all our heritage structures, wherever you picture part of India you go, north, south, east, west, I'll not name those structures, but have been existing in India. You know, why we should talk about heritage? Even if you say post-independence, there's so many buildings in all the states. To name few, the Air India building, the Reserve Bank building, all those buildings were, you know, high-rise, and they were built almost 40, 50 years back. So for India, high-rise is not new. Like the first panelist mentioned about what's the definition of high-rise, you know. So say the National Building Code talks about an high-rise building, anything more than 15 meters. Okay. Then why 15 meters? So the whole focus was, you know, basically on the safety. If you can fight the fire from inside, then it's fine. If you're not able to fight the fire from inside, which is say 15 meters or above, then it's called an high-rise. But if you check ISHRAE TC 9.12, that is the ISHRAE Technical Committee for Tall Buildings, you know, they have a different classification. They say any building, say more than 91 meters is an high rise, and then the mega rise and the high rise, whatever it is. So we are in India, we are talking about on an average a structure between what NBC says and what ISHRAE says. Of course, in India, there have been many structures, especially in past 15 years, which have been, you know, 150 meter tall, 180 meter tall, 200 meter tall. Currently, there are a lot of buildings which are going with 250, 300 meters. So your question is, India ready with technical skilled infrastructure? Obviously, the answer is yes. I'm going to say it is optimistically yes. There are a lot of things which we can improve. So to say, from the safety standards, you know, my personal opinion when it comes to the safety aspects of constructing a high-rise building, probably we need to do a lot. And as you all know, ISHRAE has already developed, you know, safety standards, maybe 3-4 years back or 4-5 years back. So that is the aspect where we have to develop. Now, since today we are going to talk about, you know, HVAC. From an HVAC perspective, is India ready with the technical skill infrastructure? The answer is yes. And why I say so is, say for a high-rise building, let's not talk about buildings just 15 meter high. Let's talk about a building with an average 80 or 90 meter. What do you require from an HV system? We require a chiller, you know, which can probably operate at a pressure or an operating pressure which is quite high. You know, if you see a general chiller data sheet, it comes with an, you know, operating pressure of say 10 bar. But it's a high-rise building, you have to have a chiller selection which can operate at higher pressure. Do we have those kind of systems in India? The answer is yes. Then when we talk about high-rise building, what is important is, since you go vertically up, there are chances of expansion in the chill water lines. You know, I'm focusing my discussion on HVAC. Expansion of chill water lines. You know, do we have systems? Do we have design? Do we have products for that? Yes, we do have systems for that. So on and so forth. So going on, is India ready with technically skilled infrastructure for high-rise building? The answer is obviously yes. Now, there can be a lot of improvement. I'm going to say, when I say improvement, that improvement has to come together with, it cannot be in isolation with an HVAC engineer. It has to be the architect, it has to be the structural engineer, it has to be the corporation. I'm going to say why I say that. When you try to design a very high-rise building, say 100 meter high, 120 meter high, what is important is you need to break the pressure in the systems, which is very important. which means you need to have multiple service floors in between a few floors. Now, the reason is when you have a chill water system for a building like 180 meter tall or a 200 meter tall, it will become very difficult to have a system, not only the chillers, but the associated, say, valves and the other periphernalias to sustain that pressure, which means you have to break the system, which means you will have a service floor in between, say at a 70 meter high or 80 meter high. And those systems will be adopted with a plate heat exchanger. So when I say plate heat exchanger, you need to have the system which breaks from 0 to 70 meters, and from 70 to say 140 meter, you have another system which will pump the chill water for the upper floors. Now, to do that, we need a sufficient space. We need sufficient height in the building to do that. So all this requires an integrated approach from architect, the client, and the structural engineer. Do we have a skilled labor to do that? Of course, that's a matter of debate and discussion, because the high-rise buildings in India are not to the extent what you have abroad. Like a few of our panelists have worked in Gulf countries. There all the buildings are tall structure. So you have the HVAC contractor or the labor who is accustomed to work on the systems. When I say accustomed to work on the system, there are a few aspects like how you support a ducting, how you support a piping system. It requires a different skill set, because when I talk about expansion, you need to leave some gap for the pipe or the duct to expand. All these things, of course, we can put, as a consultant, I can put it in a design. But when it comes on board, even the labor or the contractor should know that, these aspects have to be taken care of. So I'm being very optimistic. The future is high rise, as you all know. That's how we are going to go, because we can say that by going high rise, we are trying to use less of Mother Earth horizontally. Of course, we are going deep, because when you build a high structure, you need to go deep for the sustenance of the structure. So my answer is yes. I think you also have asked a question about how the critical room air conditioning is addressed in such mega structures. I think so from an HVAC perspective, it is not much different when you talk about a space and a space air conditioning system, because when you talk about space, it is as the same as you do for the other system. What is important is the other system which are important in an air conditioning building, which is the pressurization, which is staircase, the fire lift lobby pressurization. I think the panelists before me spoke about the toilet ventilation system. So how do we address that is a concern. I mean, it's not a concern, it's a design aspect. I'm sure a lot of us must have heard about a stack effect or a reverse stack effect. So when you go tall, the stack effect which comes into play for places like north of India or up north of India, where the outside temperature is colder and the inside temperature is warm, or the reverse stack effect where places like, say, warm place where I come from, say Bombay or Chennai or Hyderabad, where the the outside temperature is warm and inside is colder because you are air conditioned the building. So when you talk about those systems, the pressurization system, those becomes very critical, because we have to handle this other aspects like the stack effect and reverse stack effect. It's not difficult. There are many, if you design your systems properly, of course, this can be easily taken care. There's one more aspect when it comes to room air conditioning system. Again, when you go vertical, again, you should see to it that the vertical height of the ducting is probably limited to 100 meters, and restrict your ducting height to 100 meters, which means you need to have multiple service floors to take care of that. And when you talk about multiple service floor, you will have equipments placed on a working slab, because you will have, say, office below that, office above that. How do you take care of the vibration of those system? So when you talk about high rise, all these aspects come into picture, not only air conditioning, but how you relate your design with the other aspects of air conditioning system.
Yes, certainly, sir. Thank you for the brief explanation about the question. Thank you. I request Manipana to take.
Perfect. So thank you very much, Sagar, for describing high-rise buildings, technical infrastructure in detail. And you perfectly highlighted there are challenges. And yes, I have another question for Mr. Yash Sen regarding these challenges. And regarding this, we have also received one question in the question answer tab, which I would also like to uh, address by our panelist, Mr. Yash Sen. So the question is, with huge height comes great risk. Staircase pressurization, lifting pressurization, fresh air requirement, earthquake, storm, and emergency services. How an MEP engineer overcomes these risks while designing the system. And in addition, I would also like to add the question which is raised by one of the attendees, how to handle the staircase or lift lobby pressurization for buildings taller than 100 meters to ensure sufficient pressure is available in the area to deflect the smoke. So over to you, Mr. Yash, please.
Okay, Mr. Mani, the question is very precise and I have to tell many things. So first of all, I will say thank you to ISHRAE Primetime to come with this topic, because this is the future of India, because we have less land and we need more buildings. So the high-rise building is the future. So basically, if I will say with the huge height, because as Mr. Sagar told that as per ISHRAE and as per NBC, we have different characteristics of the high-rise building. Like if we consider NBC, then it will consider 30-meter above building as a high-rise building. But if we consider ISHRAE, then above 90 meters, we will consider high-rise building. So basically, this topic is the part of firefighting and the safety of the occupants. So there are two things. First, for the occupants, the first thing is the thermal comfort, and second thing is the safety of occupants. So in the case of fire event, we have to evacuate the complete building as soon as possible. And in that case, we will use the techniques which are staircase pressurization, lifting pressurization. So these two techniques we generally use as a safety in the fire event. So first of all, I want to brief about the staircase pressurization. In that fire event, we have certain amount of fresh air coming from the top, and it is coming.
Yes, sir. Can you please on your video?
Yeah, sure. So I'm visible.
Yeah, visible. Please go ahead. Thank you.
Okay. So basically, in the staircase pressurization, what we are doing is we are putting the fresh air from the top of the building, and we are just having the more pressure as of the space of fire, so that the smoke will not come in the staircase. So this calculation is very precise calculation. Generally, the MEP consultant don't do the precise calculation because there are various challenges in the design of this system. First of all, when this MEP person enters in the building is not complete, because sometimes owner give tenants that they will do all these things if they want. But if owner want to do that, the building is not complete that time when the MEP consultant goes in. So we have certain, I can say, the gaps in the doors, or we have some leakages from the building. So that time we don't know how much quantity we have to take for the air to come inside the staircase. So this is the biggest challenge I saw in the design of staircase pressurization. Secondly, I can say that this system, the MEP person will design the system, and nobody will check the system because there is no maintenance come over this systems. So this is again a big problem, because sometimes the sensor will not work after 1 year or 2 year, or sometimes the VFD is not working. So we have to regularize the maintenance of the system, so that at the time of fire event, we can use it beneficially. Second thing, in the staircase also we do the, in lifting well also we do the same thing. So we have like for the big buildings, we divide 4 or 5 floors by the one fan, or you can take the axial fan with the VFD, and that VFD is controlled by some sensor inside the space, and we have one automatic damper also. So sometimes this damper doesn't work. Sometimes there is problem with the pressure inside the well. So this we need to overcome. So basically, these are the challenges I think we need to rectify to design the perfect system. And for the fresh air, I can say there is, Mr. Sagar told that there is one stack effect that we saw in the high-rise building, in which we have different temperature inside and outside the building. So there is also different pressure inside and outside the building. Because of this, there is always a certain infiltration or exfiltration from the building. So we have to consider these all factors while designing the system, because as we know, the temperature is increasing day by day. So we have to check all the leakages from the building and then design the system. So I think this is the thing we need to consider. And the fresh air requirement, I can say that temperature is increasing day by day. So and also we have pollution, like you saw in metro cities, we have a lot of pollution, around 1000 ppm we have in Mumbai sometimes. So for that, I can suggest we can use the MVHR, which is mechanical ventilation heat recovery. This system is basically having one heat exchanger inside it. So we can take sensible and latent load both into the consideration, and we can design the system. This system will give the energy efficiency also, and it is good for the occupant health, and he will feel the comfort there. So this, I think, the fresh air requirement, we should think like that. And for the earthquake storm emergency services, I can say the biggest responsible person for this is the structural engineer, because for the high-rise building, we need a strong, experienced structural engineer who can do the multiple simulations and then come with the design. So yes, and also for the earthquake, I can say in high-rise building, we have different wind velocity above certain levels. So we have to consider all these things for the better designing of the building. So that I can say. So this is, I think, all from my side, Mr. Moni.
Thank you very much, Yash, for responding to these questions. So as these questions have been asked by many of the attendees, so thank you for responding to these questions. And the next question I would like to ask to Mr. Prakash. So that is regarding the high-rise buildings installation of chilled water piping, ducting, etc. So, Mr. Prakash, can you please provide an insight of key considerations for installation of chilled water piping, ducting, etc.?
I think lastly when I spoke, I totally spoke on this topic only, chill water piping and ducting. I think I have answered this question.
Yeah, there are some few more questions, sir. You have answered in question and answer. Can you brief on that?
Okay. No issue. Like just previously, like I said, chilled water piping is one thing. Pipe normally pipe size we can keep at around 150 or 200. That's not a big problem for us. But ducting, as because all our ducts, they are used to convey air, be it fresh air, be it conditioned air, be it toilet exhaust, be it whatever it might be. But gas and basically air travels through these ducts. So they take a lot of, they require a lot of space. So our ducting, whenever we are designing our ducting for any AC system, we have to ensure that it should be as minimal as possible. But again, the velocity of air inside the duct should not be more, because if it is more than at bends or at edges, it might start whistling. So that is one consideration what we do when we design ducting. And for chilled water piping, we have to ensure one thing, that is that different AHUs are located at different floor. So the amount of water which is being going to the lower floor and which is being going to the upper floors, the travel distance might vary. So it may so happen that the water which is going to the upper floor, they might experience more pressure drop. So what we do is we provide motorized valve and restriction orifice plate at the inlet of each AHU to ensure that pressure loss across all AHUs is same. And other important thing is the expansion tank, because when the chilled water is going to the AHU, it is at certain temperature, and when it comes out of the AHU, the temperature rises by 4 to 5 degrees Celsius. In that case, it expands. So to take care of that expansion, we have to provide expansion tank. It can be a pressurized expansion tank, which I favor normally, but it can also be natural expansion tank. But we have to ensure that our pressure loss calculation should be sufficient to back that the expansion tank, which normally, if it is an open type, we connect to the return water and we keep it at the highest point. But we have to ensure that pressure loss and the pump selection should be such that it should not happen that expansion tank it starts experiencing a backflow of water. It should never ever happen. If we don't do our pressure loss calculation diligently, then it may happen. In fact, I have experienced such a case where the expansion tank started backflooding. I think these are the key consideration for designing a chilled water piping and ducting. Keep the duct as minimal as possible. And if it's possible to avoid it, then avoid it. Like, for smaller spaces, you can use FCU, fan coil units, instead of AHU. So that if you can do, then it's better. If you cannot do it, then use ducting, but keep the size of duct as minimum as possible. That's all. Thank you.
Thank you, Prakash sir. Thank you for highlighting that particular issue. We have next question to Sagar Munishwar sir, that what care need to be taken while selecting equipment for high-rise building. In addition to that, in chat box we have one question, that what is the most important challenge for designers in high-rise building? And this question is from Mr. Sundar, Secretary IDC. And also I'll add another question from very interesting question from Mr. Kedar Patki, that is Indian firefighting system equipped to handle fire situations? So how an MEP designer overcome these situations while selecting equipment? Over to Mr. Sagar.
Okay. So so I'll take Mr. Kedar Patki's question first. Not for anything, but since it's there in my mind registered, so I'll take that question first. So the answer is yes and no both. Why I say that is, when we talk about firefighting system, it's from two aspects. One is the fire local department capable of handling high-rise buildings? There are few states, few cities which have a ladder which can go only up to 70 meters. So the part which I come from, say Thane, earlier was not allowing any buildings more than 70 meters because they had ladder up to 70 meters. So irrespective of if my firefighting system is capable or not, the system itself, they were not having that to take care. To answer the question from a mechanical aspect, yes, we have firefighting system capable of handling high rise. What comes primary importance is your pumps. Okay, so do we have pumps which can take care of high rise building? Yes, since as you go on, since it's an open system, firefighting is an open system, you need to have a pump which can develop more pressure, unlike a air conditioning system, which is a closed loop. So the pressure to be developed is less. So we have pumps like multi-stage pumps, horizontal split casing type pumps, multi-stage, which can deliver the required pressure with the given flow in a firefighting system. So do we have those pumps available? Do we have that system available? Yes. When it comes to the other firefighting system, which is the automatic sprinkler system and the hydrant system, yes. Of course, the sprinkler system per se can take only 12 bar pressure. So if your system goes more than 12 bar pressure, you can have an orifice plate or a pressure restricting device, which can control the system across your line. Hydrant system, again, no issue at all. You have to just maintain a 4.5 bar pressure at the outlet of the hydrant valve, which is again possible by introducing an orifice plate. So even if you go high, the firefighting systems, what we have currently, of course, we have those systems in place. So that's not an issue. Coming back to your question, the main question on consideration for selection of equipment for high-rise buildings. So we are talking about primarily the chill water, the chillers, the pumps, and the piping and the other associated aspects, and of course the ventilation fans and other stuff. So like I mentioned about chiller, when you go high rise, you need to select a chiller which can take that operating pressure. You need to have those valves which are in the line to take the pressure. Again, a chill water system is a closed loop system, so you will not have an issue per se of the pressure acting on the valve. But yes, when your system shuts down, the entire static load will come on that valves. And if you have a building which is 150-meter height, you need valves of PN20 or PN25 rating to take care of that. Similar thing with the chillers. As far as pumps is concerned, no issues. Of course, you can, as I mentioned, that as you go high rise, it's a good design practice that you have an intermediate brake pressure system where you have pumps installed on various floors, which can help reduce the pressure on the pumps. And the third aspect is how you select the piping and how you select the valves. So, you must have read a lot of ISHRAE journals which talk about a reverse return piping system vis-a-vis pressure independent balancing control valve. So in a chill water system, what important is when you go high rise is you need to have an equal pressure drop across each AHU and equal pressure drop across each FCU. Now that can be attained by either reverse return piping or a pressure independent balancing control valve. Again, in a high rise, having a reverse return piping, it's a cost. It's a cost because you'll have to have an extra piping running till the top and the piping coming back. So instead, you can have pressure independent balancing control valve across each AHUs or each fan coil units, which can take care of the required pressure drop across all the system. I would also like to touch upon a few aspects, like one of the panelists did mention about the staircase pressurization system. So when you select the fans for staircase pressurization system for a high-rise building, we see to it that it is divided amongst equal floors. I mean to say, if it's a 40 or 50-storied building, it's not wise to have only one fan located on the top and pressurizing the system. The reason is, one reason I spoke about is the stack effect. Like if you have a stack effect, the air will try to penetrate from the bottom and go up, which can impact the pressurization system. So it is better to have fans selected for say 10 floors, 11 floors. I'm just taking a number, but I'm saying have those pressurization system divided among all the floors so that you can maintain the required 50 Pascal pressure between the staircase and the adjoining areas as stipulated in various codes, which means you need to have number of fans located at number of floors. Why I'm stressing on this intermediate service floors is, as an designer, as an HVAC engineers, we should insist on having those intermediate service floors. Yes, it's a cost to the client. Architect may not agree, but that's required for the system to run properly. The system to run properly when it is required. So The consideration for selection of equipments of high-rise building, yes, you need to take care of the pressure per se. There was one second question also, Imran.
Basically, what are the challenges to design a high-rise building for MEP design?
I think I've probably have answered those while answering this first question. Yeah, these are the challenges. Yes, as I mentioned, taking care of the expansion in the piping, if it's a high-rise building, that also needs to be taken care when you design. Having a proper expansion devices for the piping. Secondly, if it's a seismic area, there are a few places like North Delhi, it comes under a very high seismic zone. So you should have, plus you're going vertically up. So you should have all your supports, all your piping design, having those supports for seismic application as well.
Yes, sir. Certainly you have answered all the questions, and the explanation was in line with the question being asked.
Yeah.
Thank you. Thank you for that. We'll go ahead with the next question, and which is related to sustainability. So, Minu, can we have next slide? And this question is to our panelist Yash Sen, that how and what practices help us to make high-rise building highly sustainable. So very hot topic. So I request Mr. Yash Sen to open the camera and explain this.
Okay, Mr. Imran, thank you for the question. So I think this is again a great subject these days, because as we know, we have certain goals for the climate change, and certain for net zero buildings. We are going for many net zero buildings. So I think this is my personal interest, sustainable building. And I also did some projects for the net zero. So yeah, basically I can say for the sustainable buildings, first we have to consider all the passive approach to make a building. So in the passive approach, I can say the basic is the orientation of building. So as we all know that if we'll make the big doors on the north and south axis, so it will be the great for the sustainable, because we have some software like Ecotech. So in that we will do some calculation for the sun path analysis, and by doing this we will get the optimum result for the best glazing and all the, I can say whatever the best we'll get from the sun. The next thing I can say, the landscape of the building is important, because if we have trees nearby, or I can say if we have vertical landscape, like we have some vegetation over the building, or roof garden we have. So by doing all this passive approach, we can do something better. Next thing I can suggest that we can go for the shadings also, because many types of shadings are available in the market. And I can say that there is one more thing, which is kinetic facade. So we have this building in Dubai Expo 2020. So there is one kinetic facade, and it automatically changes the all its surfaces according to the sun analysis. So this thing, I think, a great passive approach for the sustainable building. And again, I will say that renewables are the major component in the sustainable building development. And renewable, I can say that we have solar, we have wind, we have geothermal. So this geothermal thing is new, very new in India, and obviously I am also very curious to learn about it, and I did some projects also, the designing project. And so this technology is the future of India, because as I can say that solar always subjected to the intensity of the sun. Wind is always subjected to the wind velocity. But I can say the geothermal, we have the constant temperature below our feet throughout the year. So by utilizing that temperature, by that energy, we can heat or cool our building for the thermal comfort. So these are the renewable technologies we must have to incorporate in our sustainable building developments. And then I can say there are many type of envelope, efficient envelope are coming in the market. So we have to always consider the U values of the system, of the assembly. Like I can say the AAC block is better than the red brick. We all know that because we have less U value and less, so that thermal transmittance is less. So all these things we have to consider for the sustainable development. Next thing, the biggest thing, the heat gain comes from the glazing. So the high-rise building is all covered with the glazing. So we have to consider the glazing, like we can use the triple glaze, double glaze with the, there are various films also available to put on the screen, so that we can get the daylighting also, and also we can stop the thermal transmittance. So all these things I can say that this is a way to a sustainable development. And there are also we do various certifications these days, like LEED certification, we have GRIA in India, IGBC, GEM certification. So all these certifications are basically, I can say that they are good for the sustainable development, because we have to consider all our net zero goals, all our carbon reduction goals. So by considering all these certifications, we can definitely bring something in the sustainable development. So definitely, like I can say that GRIA is the most strict in India for the development of all these buildings. So I can say that we can use these certifications for further approaching our goal. And yes, so this is all from my side, Mr. Imran.
Yeah, thank you, Mr. Yash. It was a very brief about sustainability. So I think our audience got a brief, a good understanding about sustainability. So we'll thank you, and we'll move ahead with the next question. So now here comes the very interesting question in recent time, and this question is to Dr. Anand Babu, that as we are moving from smart buildings to digital building technology, what role the IoT play in design operation of high-rise buildings? And then we have another concept which is getting very famous across all over the world, that all amenities under one building concept, like shopping malls, like commercial spaces, residentials, all in under one roof. So how IoT play a very vital role for such arrangements in one building? So over to Mr. Anand. We are expecting your expert opinion on this.
Thanks, Imran. First thing, I think there was one question talking about biggest challenges for designing the high-rise building. There are a lot of challenges. Like, when we talk about a 100 meters building, taking a fresh air will be always a challenge, because the pressure outside will be much higher. When you talk about a pressure at the level of 12 feet or 13 feet, or maybe like 10 meters height or 100 meters height. So taking the fresh air inside and maintaining the IAQ levels inside the building is always a challenge. So we need to make sure that you have a proper service flow, as Mr. Sagar was mentioning. So you have a proper louver and all this. You have to take care what is the wind pressure at that levels. So you need to look into that, and the filtration levels. What kind of ambient it is there? So we need to look into the filtration levels at that place. And of course, what I think most of the place Mr. Sagar has is covered. But when you say when you have a 100 meters building, and your chill water is going up, okay, you're pumping through your pump, considering the head. But what about the pump, the water when it is coming down? So you need to consider whatever is the gravity level and all things. So you have to do a proper calculation, and your valves has to maintain that. So you have to select the valves in such a way that you are maintaining it. As Mr. Prakash was mentioning about the toilet exhaust, yes, it is very important. How do you throw the toilet exhaust at the level of 100 meters level, and you just can't throw the air outside, because you're going to have so much of back pressure from the ambient that you have to see what best you have to do. I mean, what is the proper location for that to throw the air out? So these are very different challenges. It actually acts upon the dynamics of the building. Okay, even the wind pressure on the glass. So what kind of a wind pressure? When you calculate the U value, we see what is the outside film of the glass and all things. So we need to consider all those levels, because the more we go up, the temperature difference will be there. So you need to consider that. Then there was another question with Mr. Gunjan was talking about the net zero. So IoT comes into the same place. Like when you talk about the AHUs, there are so many AHUs now. We talk about many companies, they're coming with IoT based AHUs. Now we are earlier, HVAC industry was way away from IoT or AI, artificial intelligence and all things, but we are catching up very fast. Like our youth is catching up in ISHRAE, IoT is catching up in HVAC as well. Most of the issues are independently handled by IoT, where you can actually use that with the mobile. When you talk about a 100-floor building and you say that at 99th floor there's some problem, so how much time does a maintenance guy take to go there? Or rather, when they complain, how much kind of time it is going to take? So when you have a IoT kind of a technology where you can see everything on your mobile or in your laptop, of course, BMS is also one of the things, but IoT is little advanced to BMS, where we don't have any cablings and all that for the IoT technology. So when the person can see what is the issues are happening, like the lift, it stops in between. So you can see what is the problem and all the things, like or the chill water pumps if there is an issue. So all these things, IoT plays a major role now. This is a new vertical for the youth to look into, because we are going towards technology now. Earlier it was more of a conventional way of doing things, but we are going towards that. Yes, in HVAC industry we have a skilled labor, but we have shortage of labor as well. So this IoT plays a role where it bridges the gap between the necessity as a skilled labor and the requirements. So or the technology, if you can put it. So these all things are addressed by IoT. Coming to the point of Mr. Gunjan, I know when we talk about a high-rise building, maybe we have around 100 families, or maybe say okay, even 100 families is around 100 into 4 people or 400 families. So what kind of air conditioning they're going to use? What kind of the wastage which is going to come out? The LED lights what we are going to use. So we can actually reuse all the system, like whatever the wastage is coming up, STPs are there. Now most of the cooling towers are run by our STP water as a makeup water. All our landscape are running with this. Now we are going with the vertical gardens in most of the IoT or high-rise buildings. So IoT plays a major role, where we know how much water to give to what kind of a plant at what temperature and all. So these all things are coming up. Yes, Europe has started that. I think it will soon it will catch up. Coming to your next question, Imran, like all amenities in one roof. Thanks to COVID, I think we all started working from home, which was especially for HVAC, it was an impossible target. For people working from home, it was impossible. But now we know that yes, we can work. So now the buildings have to be much more smart. We have to reduce. Like when we talk about Parivartan and Paryavaran and Parivartan in our theme. So this way it comes in. We have to restrict the travel of the people. I'm not saying every time, but the person going from or you have public transport or a cab or something. You are actually adding to the pollution to the land. Now, when a person is in the same building, having of people going around will be reduced. The most important thing when you talk about commercial, shopping mall, and residential, when you say shopping mall or in a commercial building or office, you can see the timing of this timing will be around 9 to 5. So most of the people in the residential will be working in the office or in the commercial building. But in the night time, your shopping malls and commercial space are reduced. They are not working. So the residence is on, like the is in the residential side. So use the diversity where based on our building topography and building requirements, it actually reduces. So same thing for the commercial building or with a residential thing, the timing of the things is different. You're using the same chiller for your residential as well as you're using the same chiller for your for your commercial space. So this gives more. I know you are improving your power consumption is reduced because you don't have much of chillers running for both the system together. Second, more important thing is your space is reduced because this the amount of chillers required for residential as well as the air conditioning. I'm talking about the bigger buildings, not the smaller ones. So this all is reduced. So in a way, this is a new concept. I think this is going to catch up in coming days. I think we can see we all working in one building. working in an office in the same building and going for a shopping in the same building and having a party in the evening in the same residence. I hope I have answered your question, Imran.
Yes, yes, certainly, sir. And we were waiting for this answer. So I believe the audience has well received this answer. So now let's move ahead with the next set of program we have now. Um, yes, it will be a live interactive session with the panelists. We'll be unmuting some of the participants to ask live questions. So since they have listened to you all the way on various topics, so I request the audience to unmute yourself, or you can raise your hand so that we can unmute and we can connect you directly with our panelists for your expert opinion. Yeah, there are two hand raised. Minu or Raviji, can you please unmute them?
Yes, sir, doing that.
Please unmute Ashutosh Vyas. Yeah, Mr. Sundar is there, the secretary from IDC. You can unmute yourself, sir. Please go ahead with your question, please.
Yeah, thanks, Imran. Thanks, Maniji and the entire panelist. It was really a fantastic session and a lot of learning for me personally too. Lot of questions I could able to have the answers. And the timing is also very good Saturday evening, and I'm sure everybody have enjoyed the session. My question is on the project management part of it. Normally what happens, the project manager will always have the pressure of project completion date and timelines from all the stakeholders. So my question is, what we can do to reduce time in the construction of high-rise buildings?
And you can specifically mention, sir, from which panelist you want to have this answer, because it will be very difficult for us to choose one.
So even I have the same challenge, Imran. So that's why I just kept quiet.
Imran, I'll answer the question.
Yeah. Thanks, Anand sir. Thanks.
I'll take that. So first thing is there's no difference between constructing 100 villas and constructing the high-rise building. It's one and the same. You're laterally constructing it. This is you're working vertically. But as you said, yes, you have a limited space. All the services are going to work in the same zone, and the time limits are pretty strict, tight actually. So what we can think is a proper planning in the sequence of the work, because first thing is I did one project in Saudi where it was a medical center, a medical hospital, basically designed by American consultants. The project was designed for 3 years and executed in 2 years. Okay, so the design part took almost 3 years. So they have even designed the proper shaft. They designed the wall openings. They designed all this, wherever the services are getting crisscrossed and all the things. So every part of them has been designed. So the major crux in execution remains in the design. If your design is run in a proper way, and when it can take care of all the things, definitely I think your question will be answered, sir.
Yes, sir. Yes, thanks.
Can I add to what Mr. Anand Babu said, Imran?
Please, sir, please.
Yeah. So when it comes to high rise, what is important for the project to complete fast, more than an HVAC, is from the structure. Like nowadays, you have many different structures which are coming up, like a tunnel form structure, where the entire structure is made in the factory and they come out and install it. Now, how does it help is, once that is done in the factory, all the associated, mostly, I want to say, it doesn't help HVAC much, but say electrical works and plumbing works come from the factory. And when you come onto the site, you have to just install it. That is how a lot of projects abroad are done. High-rise projects abroad are done. Like we were involved in a project in Africa where the 12-floor structure was done in 3 months' time, and the entire plumbing and HVAC shaft came as a tunnel. So when it comes as a tunnel, you don't have to, do the plastering of the shafts, which takes time. Why I'm saying from a project management, as you know, in a construction industry, you cannot lay a chill water pipes directly on the shaft. The shaft has to be done, it has to be plastered, and then. So if the client uses some technologies for the structure, our HVAC installation can get, easily adapted to that. So it has to come from the structure for the project to move fast.
Yeah, I would like to add to what Sagar is saying that as far as structure is concerned, now we have two concepts. One is a pre-engineered building that reduces your time considerably, and the second is where you replace all your brickwork and you use RCC only for your wall. RCC, the entire building is your of RCC. So that also reduced. But in case of RCC, your cost of building will go high. In India, we are still facing a situation where we have to grow and we have to ensure that we don't spend much than what we have in our hand. So if you are thinking of completing your project on time or before time, I would say pre-engineered building is one option which you have. Second is, you can have your entire building of RCC. And what Sagar rightly said, that for your building to complete first, you need your structure to be erected properly within time. And ACBS work can be done really quickly. And I totally agree to what Sagar just said.
One thing is, like Mr. Praveen Kumar said, and if now, we have technologies like BIM, I'm going to say BIM modeling, 3D Revit, where you can do a precise plant room design. If that is done, you can have all the chill water piping, plant room piping, prefabricated from a factory. You come and install, not with welding, but with flange connection. That's also a faster way. Skid mounted pumps, that is one way where, you can save time in a high-rise building. And all these technologies are already adopted abroad. The reason is the labor is costly abroad. So everything is done in factory and you just come and, it's fit to site. But in India, is it possible? I'm very optimistic because we have to use the technologies like 3D, Revit, BIM. If we have those technologies, we can certainly use that.
Yeah, Sagar, I think
anything to add?
Even in India, sorry, Imran. Even in India, the labor is getting costlier now. So getting a labor is pretty challenging.
Yeah, post-COVID, yes.
Right.
So, yeah.
I also know one of the company in China that is broad. They have office all over the world. So also they are trying in India. So the company name is Broad. So they basically make the PEB buildings with all the air conditioning and all complete envelope. They manufacture in the factory and then come over the site and install it. So Mr. Sagar, I think that we have to be optimistic about the situation. Maybe it will work in India.
True.
Yes, certainly. It was a very interesting question from Mr. Sundar that it has dragged all the speakers to give their input. So it was really nice interactive session. And I asked Mr. Ashutosh Vyas to unmute and ask a quick question since we are running out of time.
Thank you very much, Imran. Let me first of all congratulate the entire zonal team for this fascinating session. Which everybody is, really pleased to attend on a Saturday evening. It was a really good discussion from the speakers, Mr. Anand Babu, Sagar Bhai. My question is, when we are, when we are seeing this high-rises building, am I audible?
Yeah, you are
Hello.
audible. Please go ahead.
Okay. Recently, Ahmedabad was given the permission for the buildings buildings having floors till 70 floors in a single tower. So when such kind of approval is given, what kind of measures should the HVAC contractors, consultants should be looking at in the near term to mid term future? What should be the changes we should quickly be doing in our standard operating procedures when we see such kind of projects coming up in next 3 to 5 years? Because it is very difficult to adopt to whatever technologies some foreign companies are doing at their in their environments and in their projects, it is very difficult to adopt to them overnight. But what are some of the easier things that we can start doing?
So the question was basically he wanted to understand what is the National Building Code of NBC says about the high-rise building.
No, actually, I think he's asking that just now we are getting approval for in different cities for building floor up to 60 or 70. What are how we to adopt to those things? Am I right, Mr. Ashutosh?
Yes, sir. The thing is that HVC fraternity in this region is, used to doing projects of not more than 15 floors or 20 floors.
Exactly,
So
exactly.
when we are going to get projects as tall as 70 floors in
Yeah.
next 3 to 5 years, what should be the changes we should be ready for?
Yeah. Sagar, before you speak something, I would like to add. I think Sagar is an optimistic person, is a highly optimistic person. But I personally feel that our laborers in HVAC system, they're not adequately paid. First off, we need to do is those who learn HVAC work, particularly erection of piping and HU and duct and everything. We should retain them, because as an engineer or as a designer, each time you cannot go to the 60th floor or 70th floor during erection, because reaching there is very tough. So first is, if we develop a laborer or a skilled labor in HVAC industry, then we need to somehow retain them, and by retaining them is one. Retaining them can be done by increasing their pay and giving them adequate salary and all. But right now we are more comfortable in an office building which is 20 floor or 25 floors, because I also have designed only up to 25. So right now, if I'm asked to jump from 25 to 70, it would be really difficult for me not only to design, but to find a contractor who can erect that. And now I would request Mr. Sagar to add on this. Sagar, what is your opinion?
No, perfectly said, Prakash. You've asked a very tough question.
Yeah, exactly.
And knowing you, I know you will come up with tough question. First, though, it's on a lighter note, but very serious. ISHRAE has developed two beautiful standards. One is safety at HVAC construction sites. Okay, when you go high rise, it is very imperative that these standards are adopted even by designers. It's a responsibility of the entire fraternity that these standards, which are developed for the safety of HVAC work at site, should be adopted. That is number one. Number two is of late, the new standard which has come up is the commissioning standards. Okay, what will happen is, I probably feel that, of course, maybe Mr. Babu, Dr. Anand would add on to that, is how do we adopt these IoT systems, even for, commissioning of the system. If you ask from an execution perspective, it is not that difficult. For example, if an HU has to be bought in, you can disassemble the HU, get it on site and assemble it. So for a labor who has done a building with 20 storage or a 70 storage, for him, it is not much different. He can still assemble the HU, go there on site and assemble it. What will impact is the commissioning. When he goes to commission the system of a staircase pressurization or toilet ventilation, like Mr. Prakash Kumar was saying in his first answer, all that will become very, very critical, because you're talking about, maintaining and balancing a 50 CFM, in a 100-meter tall building. So that's where how you commission the system, what standards you adopt, what sophisticated measures, calibrated instruments you use will become difficult. From an execution perspective, I per se don't see it would be that difficult. What we have to focus on is the safety of the labor and the safety of people who are going to work. That becomes a paramount importance.
Great.
Yeah, Imran, can I just extend to that question?
Please, sir.
Whatever Mr. Sagar and Mr. Prakash have said is absolutely true. I mean, and whatever he was mentioning about the commissioning standards and the safety standards, yes, we have. But how many of our technicians or how many of our engineers are certified in HVAC industry? Okay, well, this actually answers your question of when we are saying who are the laborers or who are the technicians or who are the contractors and who are the design engineers who are working in this our industry are certified. So what we do is we just work on our experience. We don't work on the actual requirements of the code or the or the requirement of the industry. So first thing is, as you said, now the buildings are coming up with 70 floors, 80 floors. The existing team, they need to learn more. I mean, they have to go beyond what they know. So they have to go with the ISHRAE is like what Mr. Sagar was mentioning. ISHRAE has so many good certifications. You go ICP certification, ICP design course is there, ICP service course is there, which talks about all those things. Whatever questions are there, that is answered in this certification course. When you have a trained, qualified people in our industry, automatically the problems of the future can be resolved. So this is my answer to this.
Thank you, Anand sir. We have many questions coming across in our chat box as well as question and answer window. But since we are running out of time, so we would like to conclude, and I would like to thank all the speakers, and I hand it over to Mr. Manikhanna.
So thank you very much. Before this, if Srinivas ji, National Chair, if he is available, he can conclude after giving remarks on all the discussions, please.
Thank you very much, Mani. And it's so overwhelming that we have been time is running like I think we are at overrun by about 40 minutes, but still the participants are very much interested to know the answers what is being given by our expert panelists. Thank you very much for your insight on the overall view of high-rise building concepts in terms of the geological location, sustainability, energy saving features, how the maintenance has to be taken care, and the ventilation and thermal comfort at the various levels of the building, and the wind tunnel effects, and as well as the flow effects in the pressurization, which has been covered by our panelists, has been really appreciated. And also the insight on the codes and standards has also been well addressed in terms of the fire and life safety systems, which is most important in high-rise buildings, has also been addressed. And now the current trend is moving towards the digital transformation of the buildings, which Anand has also covered for the mixed-use development, how the systems has to be designed for the high-rise buildings. And this is a very fantastic show for all of us, and we've learned a lot of things from us. And I would like to conclude this session with this, and we will be coming with more and more primetime shows now by seeing this overwhelming response from all the participants and the ISHRAE members. Thank you very much first.
Thank you very much, Srinivas ji, for your concluding remarks. And at the end, I would say thank you to each and everyone for participating in this first primetime show for this society year 22-23. And I must say, this is a great effort have been put by Imran along with the support of all zonal chairs. I thanks to the national leadership of ISHRAE, President-elect, and all the national team who have supported much to organize this first primetime event. And Mohammad Imran for preparing these presentations, these questions, and the flow, how the programs went well. This is the success. And thank you, Imran, for your hard work in this regard. And I must thank to all the speakers, to the panelists, Mr. Anand Babu Rao, Mr. Akash Kumar, Mr. Srinivas, Mr. Yash Sen, and Mr. Sagar Manishwar for all their views, for all their responding to all the questions. So thank you very much. And I must say thank you to the HQ team, HQ support team, Ms. Meenu and Mr. Ravi Kumar, because they are the backbone of organizing such programs at large. Also thanks to all the participants, because without those, we cannot conclude this program with much success. So thank you very much to each and everyone for attending, for participating, and for supporting such events which are being organized by Youth at ISHRAE. So looking forward to your support, to your presence in the upcoming such primetime series in the coming months. So with this note, I must say thank you to each and everyone. Thank you, Imran. Thank you all. Thank you all.
Thanks, Mani. I have one thing to say.
Thank
here.
you.
Yeah, Mani, we'll take the questions, whatever questions are there which we have not taken. You can just send us a mail so we can answer them with the answers. At least in that way we can justify the questions, whatever they are.
Yes. True. We'll get Minu. So whatever the question we have received in the question answer window, so we can send it to the panelists. So they will respond according with the best of their choice, please.
Definitely, sir. With the amount of, with the way the audience has reacted and the way you have responded to the answers, I got an idea that we'll have a part 2 of this session very soon. We'll take the questions for the next prime time, and then we can have a further another session on this. So thank you all for
thanks everyone.
Imran, just tell us the date when is the second session will be there.
This is what I was talking. So
thank you.
Of excitement.
Thank you, everyone. The entire youth committee. It was an excellent idea, and really appreciate. And because you drove it very well. That is why we had this participation, and just amazing. I'm proud that and part of you all. Thank you so much. Thank you. Thank you.
Thank you, everyone. Thank you all. Good night.
I think youth rocks as always. So let's keep rocking. Thank you.
Thanks. Bye.
Thanks.